Hello students, welcome to the next lecture on the PY questions on complex analysis. Today we will discuss about all those questions from the part B and C from the year 2011 to 2023. As usual, we will discuss all those questions with the help of the shortcut tricks. Myself, Dr. Harish Garg. You can simply follow my YouTube channel, Dr. Harish Garg, else simply WhatsApp join by scanning this code. What you will find on my YouTube channel, there is a playlist of the CSR UGC net where you can find the PY question of the real analysis, linear algebra, differential equation, ordinary differential equation, and as well as many more in my playlist are here. So let's start with this video. So first question is from the June 2011. What is given to you? F is any complex value function such that V is given to be as here. Then is a holomorphic and then so on. So what is the property of the complex value function? So we all know this is analytic. Fine. If it is holomorphic, then it is analytic when this real component and the imaginary component satisfy the Laplace equation. What is the converse of this? If it does not satisfy the Laplace property, then it is not a analytic. So look at that. Firstly, we will check about the second derivative of this 0. What is the second derivative of this is 6xr. Now clearly says that this does not satisfy this is not 0. That means this property is not satisfied. It means V does not satisfy the Laplace equation or harmonic function. It means this is not analytic. So F cannot be a holomorphic, that is analytic for any choice of the V is the right answer of this problem. Another question is from the year 2012 which is similar to this. Here instead of the V it is my U. Again you can see Uxx is my 0, Uyy is my 6x. Fine. Now clearly see that the sum is not 0. So it means U is not harmonic function. So what is the meaning of that? If it is not harmonic, it means F is not analytic or holomorphic. So again this is the correct option, rest all are cancelled. Next one is P and Q are the two non-zero complex number, then if and only if result is 2. So you have to provide the counter examples. What is the two simplest P and Q so that this option will be cancelled out? If I simply take both as a 1, it is a complex value function. Fine. So what is that? What is my P of complex? This is my 1. When it can be it's analytic. There are the two properties. Firstly, it satisfies the CR equation in terms of the x and y. Second is if you take the partial derivative with respect to z complement of f, if it is 0, then we can say this is analytic. And clearly says that if I consider this as my f, then the partial derivative is my 0. Fine. So this is my analytic. Is the converse true? What is the converse true is there. So P is my constant. What is the Q? P is my constant, but what is my Q? It is not. So this is not the counter example to discard them. If I say here Q I consider as a dz. So what is the meaning of that? P is my constant satisfied. Is it true? What is the P of this? This is the z bar, and clearly says the partial derivative of this is non-zero. So it is not analytic, but it is given that analytic. It means P of z is constant is cancelled out. Fine. Here when P of z is P and Q both are here. So how you can do that? I can reverse them. If this is my here, what is the meaning of that? What is the P of Q? This is z, and what is the partial derivative is my 0, which is analytic. But you can see P into Q is not a constant, so this option will also cancel out. What about this option? Again, if I look about this option, so what is that? P this into 1, which is not a constant, so this is a cancel out, although this is analytic. So right option is only my third is the remaining. Okay, look at this one. So F satisfied this, that is the harmonic function is satisfied. Then which of the following is my true? Holomorphic, analytic are there. So if I just consider this as my here, firstly for the G. So what is my Ux? My target is to prove Ux Vy and uy is minus of vx. So firstly u of x, this is fxx. What is the v of y? So v is my minus of this, so y is fyy. Clearly says that if you add them, if you subtract them, it will be 0. So it means this property satisfied. Fine. So look at the second property, u of y. So if you take as u of y, so that is fyx, and what is the v of x? Is minus f of xy, and again clearly see that both are satisfied. So it means this is my holomorphic. Look about the h. If I consider this is my h for the h, and this is my here, so what is that? This is similar to this only for the negative sign. So if you consider this as a ux, this is fxx, this is vy is fyy. Clearly says that this property not satisfied because the sum is a 0, not the difference. So this is not holomorphic. So G is holomorphic, H need not be a morphic, rest options are the cancel. Okay, f is a non-constant entire function. Whenever there is a non-constant entire function, you always think about the one counter example. You all know this is a non-constant entire function. V and U are here, then which of the following is false? Okay, so look at the first property, which is true. Why? You can see that which is always true. This is the CR equation, which is a true statement, but we need a false statement. So this is not true. This is a false because it is not satisfied the CR equation. U of y is not be there. So this is my correct statement. Only one correct option is there. So that's all. Otherwise, how you can find the third end? You know what is the derivative of this? Ux I cap and uj I cap, or if in terms of the complex number, you can simply write this as ux plus iota uy. So what is the modulus of this? So this is root of ux square plus uy square. Now for the CR equation, ux is nothing but my vy, uy is nothing but my minus vx. So I need a ux. So this is a ux square. What is a uy? Is minus of vx. So if I substitute here, this is minus minus plus are there. So this is a correct statement. Again, this is now in terms of the uy. So uy I can written as a vx, I can written as a uy, ux I can written as a vy. So this is also the correct statement. Only false option is my B is the right answer. Okay, f is my analytical function, z is there, u is the real, which of the following statement is correct? So look at that. If this is my analytic, fine. What is the meaning of that? It means ux is vy, uy is minus of vx, or you can see the partial derivative with respect to this is my 0. Second property is u and v will satisfy, what is satisfy the harmonic function, that is Laplace equation. This will be 0 and this will be 0. So you can see that the first property is my harmonic is there. So this is the correct statement. Second is my harmonic with respect to v. So this is also satisfied. Now look about these two properties. So we can see about here. What is that? I can take uy. So what is that? First property is uxy. Second property is uyx. This is our target. So I can differentiate this with respect to x. It is uxy is equal to minus vxx. I can differentiate this with respect to y. Uyx is minus here. So now if you add them, it will be minus of, by using this property is a 0. Fine. And this is uxy plus uyx is my 0. So this is not true. This is a true. Why this is true? Now this is for the v. So v of y. So if I take this with respect to x, this is my here, and this is with respect to y. So v of yx is minus uyy. Fine. So how you can do that? Sorry, this is a plus. U of y is plus. So if you add them, it will not be a 0. But you can see, if you subtract them, then it will be a 0. So this is the correct option. And from here, if you subtract them, it will be 0. It will be 0. So they are equal, but it said sum will be equal. It's cancel out. A, B and C are my correct option. Okay, which of the following df is the complex function satisfy the CR equations? What is that? Df is C. We have to check here. When the df will be the complete complex plane, when the function is analytic. When the function is analytic, then df will be C. So you have to check that which of the following is analytic. Look at the third option. Partial derivative of this function with respect to x is 0, z bar is 0. So this is analytic. So this is the right answer. Look at that. This is my u. This is my v. So what is the ux? 2x. What is the vy? 2y. They are not equal. So it means this is not analytic. Similarly, this is my u. So what is the u of x? Minus alpha sine alpha x. This is my v. So what is the v of y? This is minus alpha sine of alpha y. They are equal only when x is equal to y, but this is for the complete. So this is not there. Look at the first option. F is z over 1 plus mod of z. So I can written this number in terms of, I can written like here. Now you can take the partial derivative with respect to z bar. So the z is a constant, so I can written as whole square into the denominator is this plus of here into z. So clearly say that this is my non-zero because it is a z over this, it's a non-zero. So it is a non-zero, so it is not analytic. So the right answer is only C is the correct option. Look at this is the June 2015. How many elements of these elements are there? Remember, if I say any of the set such that z raised to power n, or instead of the z is a real line also, x raised to power n is my 1 and x raised to power k is not equal to 1 whenever k lies between n, then the number of the elements which satisfied this is my phi of n. If you remember the number theory, how you calculate phi, we will see. Here we need a plus 1. Remember, this is a plus 1. But here this is minus 1. Can you make this as a plus 1? It's a 120. So it means if I compare them, n will be my plus 1. Here also you can see this is a plus 1. So this is my z of 2k is not equal to 1. This satisfied, and it means this is my 2k, n will be my 120. So there is no problem about it. So what is the answer is phi of 120. How you can write the phi 20? You can convert this 120 into the prime factors. So it is 2 raised to power 3, 3 of 5. 2 raised to power 3, 3 of 5. So I can written this as 2 raised to power 3, 2 raised to power 5 and 2 raised to power. So how you can do that? If I say this is n raised to power p, the answer will be 1 minus 1 over n. Fine. So you can see this is here 1 minus 1 over 2, 3 raised to power 1, 1 minus 1 over 3, 5 raised to power 1, 1 minus 1 over 5. So 8 by 2, 4, 3, 2, 4. So what is that? 8, 32 is the right answer of the problem. That's a simple shortcut tricks for you. Remember this formula for there. Now, whenever you have to integrate this, you always draw the circle. What is that? Center is minus 1, radius is my 2. So it will be my minus 3, it will be my plus 1. This is my here. Fine, this is my plus 1, this is my minus 3. Now look at that. I can written this function in terms of here. Now if you substitute this as a 0, you will get z as a 2. If you substitute this, you will get as a minus 2. Look at which point lies here. 2 lies outside, so there is no worry about that. Minus 2 here. Fine. So minus 2 is here. So you can skip this portion. The rest part is here. You can substitute minus 2 as here. 4 over 2 plus 2, that is 1. So whatever the answer is there, multiply with the 2 pi iota. So the answer is 2 pi iota. We will see the several examples in this video based on this trick. Look at this again. So what is that? This is dz over z4 minus 1. So I can written this number as z minus 1 z plus 1, z plus iota, z minus iota. Now you can draw the curve. Radius is, center is iota. Iota means 1 comma 0. This is my 1 comma 0, sorry 0 comma 1. Center is 0 comma 1. Radius is half. So half this and this. So this is my circle. This is my 3 by 2 and this is my half. So look at that. Corresponding to this is a 1. So 1 comma 0, that's a real. 1 comma 0 here, which is lies outside, is a 0. This is my minus 1. Minus 1 lies here, it is outside the circle, it's a 0. This is my minus of iota. How you write the minus iota is 0 minus 1. 0 minus 1 is here, which is outside them, it's a 0. This is my plus iota, that is my 0 comma 1, it lies here. So only this portion, you can skip this portion, find the value. This is my 1 over, so 1 over, I can substitute z is iota. This is minus iota, sorry. So I can substitute here. So this is minus iota minus 1, minus iota plus 1, and this is, sorry, I think this number is my z minus iota. So if I say this is a z is iota, so you can substitute z is iota here. So it is a 1 over 2 pi iota times iota. So this is iota minus 1, iota plus 1 of 2 iota. So what is that? This is iota square, that's a minus of 2 minus of 2 iota into 2 pi iota. Will be cancelled out, 2 will be cancelled out, it's a minus pi by 2 is the right answer of the problem. So that's a very simple. Whenever you have to find, remove the other portion and you will get the right answer in a very simple manner. Okay, which of the following is equivalent? Remember, 2 a and b are equivalent over the complex number when rank of a is rank of the b. A and b are equivalent over the complex, over the real lines whenever rank of the a, rank of b same, and signature of the a is signature of the b. How you find the signature? Number of the positive eigenvalues minus number of the negative eigens value. Now look at that. I can write this q in terms of the, it's a quadratic, it's a 4 cross 4 because it has 4 variable. So this is the 1 1 1 b, rest all values are 0. I can written p. Second is, it's again a 4 cross 4, x square 1, y square 1. This is cz, so I can written this as a c by 2, c by 2. Rest values are my 0. This is the meaning of this. Fine. Now, is it equivalent over q? If b and c are non-zero, what is the rank of the q? When b is my non-zero, 4. Rank of the p, when c is my non-zero, so you can see there are the 4 non-zero columns, so rank is my 4, so it is equivalent over here. P and q are equivalent over the r if b and c are the non-zero real numbers. Fine, rank is same. What is the signature? If b is my non-zero real numbers, so what is the signature? What is the number of the positive eigenvalues, number of the negative eigenvalues? Positive eigenvalues are confirmed 3, negative is 1 if b is my negative. Look at that. If c is my negative, the number of the positive eigenvalues are my 2, negative eigenvalues are my 2, and you can see the difference is my 2, difference is my 0, which is not same, so it is not equivalent over the r. P and q are equivalent over r if b and c are non-negative, non-zero complex number with b as a negative. Once b is a negative, what is the eigenvalue of this? For 3 positive, 1 negative. What is the eigenvalue of this? 2 positive. What is the c? C is any non-zero. So if both are positive, then what will happen? B and C are non-zero, but B is negative. If C is my positive, then the eigenvalues are positive. So you can see it's a 4, it's a 1, it's not be there. But if C are my negative, it means 2 are my negative, then again it will not be there. P and Q are not equivalent over R if C is equal to 0. If C is 0, then what is the rank of the P? Rank of the P is 2, but rank of the Q is 4, which is not equivalent, and he said not equivalent is the right answer of this problem. So you can see about here, you remember that this B is negative. B is negative, so it will be my 3 positive, 1 eigenvalue. B, now here if C is my positive, then there are the 4 eigenvalue positive. If C is negative, then there are the 2 eigenvalues negative. So what is the signature? Signature in this case will be either 4 or either 2. In this case, its signature will be my 3, so which is not same. Okay, A is my 3 cross 3 such that A cube is my minus I. Then A has the distinct eigenvalue. It is not always true. If I consider A is my minus of I, identity matrix, fine, which is also the complex number, then what is the eigenvalue of this? Minus 1, minus 1, minus 1, which is not a distinct eigenvalues. A is diagonalizable over R. You can also see what is the eigenvalue of this is. These are my here, and over this complex number, because what is omega? Omega is root 3 by 2 iota. Fine. Similarly, omega square will be plus, so it's a plus minus, which is a distinct. Once it's a distinct eigenvalue, then we all know it is a diagonal. Once we know it's a diagonal, then you can return this number in terms of the eigenvalues. Minus 1 here, rest all are 0, so it's a triangular also. Is it non-singular? What is the determinant of this? Is my minus omega cube is my minus 1, which is a non-zero, so it's a non-singular. So the right answer is my 2, 3 and 4. Okay, A is my 10 cross 10. A is my 10 cross 10 matrix with the complex entries are here. So this is my column C1, this is my C2 and up to C10. WA is the subspace of the 10 here spanned by AN, where A is greater than. So it's a subspace. What is the dimension of the WA? So clearly say it will be less than of the dimension of, if I call this as a matrix M, of this M. Why? Because WA is the subspace of the matrix M. So the dimension will be here. What is the dimension of this? It's a 10 cross n. So maximum 10 linearly independent vectors will be here. So it will be less than or equal to 10. So first is the right answer. Strictly less than 10, not necessary. Equality will be here. 100 will not be possible. 100 will not be possible. A is the right answer. Okay, now this is the next category. How you can solve such kind of the problem. Whenever this is given to you over the circle, you have to find F0 and same. Remember, whenever this is the nature of the question, you always try to write in terms of the Z. Means I can return Z is 1 by n. So n will be 1 over Z. So it will be written as of here. Now it's a complex number. Now what is f of 0? You can see f of 0 is my 2 over 3, satisfied. What is f of 3? F of 3 is my 2 over 6, what is 1 over 3, satisfied. F has a simple pole. How you find the pole? You can put denominator as a 0. So Z is minus 3. It's a single, so it's my simple pole. It's satisfied. No such pole exists, cancel out. No such function exists, cancel out, because the function exists here. So the right answer is A, B and C. Okay, F is the analytical function on the unit disk, that is on the unit disk R. F is constant, fine. Whenever there is a term which is a constant, you have to think about the two things. Firstly, you have to prove F is entire, and if you prove F is bounded. If you prove that these two things, what is the meaning of that? It is my constant by using Leibniz theorem. Fine. Or instead of the F, you can see instead of that you can either prove either your real part or imaginary part is my constant or bounded, or constant or bounded. If you prove that, it means F is my constant. But look at here, nothing is given to in the form of the function. Then we will use the concept of the limit point. What is that? If like here, you can find the limit point of this, you can find the limit point of this. What is the limit point of 1 by n? 0. This is also the 0. Is 0, what is the limit point? Is if it belongs to the domain. Is it belongs to the domain? Yes. So then by the identity theorem, f is my constant. There are the two methods always to prove that f is constant. One is the limit point, second is this property. Here function is not given, so I have found the limit point of this is a 0. This is also a 0, so both belongs to this, is a constant, true. Here z is half, clearly say that this is my 1, half is my lies inside it b. Fine. So 0 is also the part of the half, so this is also the limit point. What is the limit point of the 1 by n square? It is also a 0. So again 0 belongs to this, it's a here. F of z is 0 for all z belongs to this. What is the limit point of this? It's a minus 1 to plus 1. It's a limit point of this. So which is again the part of this, so it is also satisfied, is the right answer of this problem. So for this example, all are my correct options for this case. Okay, f is there, so singleton, and here what is s is given to you? S is given to you of this nature and t is given to you of this nature. Fine. Now again, limit point of this is 0, limit point of this is 0. So what is the meaning of that? F is my constant. Fine. So we can say f, so what is that? F is my constant. So we can say f of z is z. From here you can see 1 by 2 is 1, f of z is my here. But we already see that f is my constant, so I can see by the identity theorem. What is the identity theorem? This f is equivalent to the my identity. So once is identity, what is the cardinality of this f? 1. That is the cardinality of the s is my 1. What is the meaning of that? S is my singleton. S is my singleton. Fine. Now this first option is correct. So both, okay, fine. T is 5, that's to cancel because it's a singleton, so cardinality must be 1. Look at the t here. What is the limit point of this? 0, as n approaches infinity. This is also a 0. Fine. Now can you find a function? So can this function will be here? If I take 1 over 2n plus 1 is my z, so what is my n? So I can return this is my 2n. If I substitute here, this is 1 minus z over this. This is my of this. Now clearly says that this is my unit disk. So clearly say that this is my not continuous at z is equal to 1. If it is not continuous, it means if is not differentiable at z is equal to 1. So what is the meaning of that? If f is not differentiable, it is not analytic, so it means f does not belong to the t. So what is the meaning of that? T is my empty. So there is no such function exists such that this property will hold. So t will be the phi, s is my singleton is the correct answer of this problem. Again this is here, so we can define in terms of the z. So if I take z is my 1 by n, so n is my 1 over z. So the function will be my 1 over 2 plus z. So f of 0 half satisfied, f of 2 1 by 4 satisfied. What is my pole? Pole is minus of 2 and it's a single, so it's my simple pole. That's satisfied. No such morphic function exists, cancel. Okay, f is my non-constant analytic function. So always remember non-constant you have to take as e raised to power z. Okay, then look at the first option. Again, if I write in terms of the z, it will be minus of z. By taking z is 1 by n, it is my z square. Fine. Now how you think about that? If you say f of z is my z square by the first property, if I take z is my minus 1 by n, then by these two, can we get the same function again? This is n is my minus 1 over z square. Again you can see is same. So what is the meaning? This is true for all the values of the z. So this is my correct option. Look at the second option. If I take z is my 1 by n for the first case, so this is my f of z, this will be my z over 2 plus z. Fine. If I take z is my minus 1 by n by using here, so n will be my minus 1 over z. So what is my f of z? F of z will be my 1 over 2 minus 2 over z plus 1, that is my z over z minus 2. You can see both the functions are different. Fine. So it means this property, like f of z is f of here, you can either is a z over 2 plus z or z over 2 minus z. So there is no function exists which satisfied here. So this option is cancelled out. Look about this third option. So how you can satisfy the third option? So look at that. This is a counter example. If I start from here, what is that? What is the f of this? It is 1 by n. Fine. So what is that? Is it less than of this? For all n, what will happen if n is equal to 1? My target is to prove this is my here. When n is equal to 1, what is that? This is e. This is my e and this is my 2 raised to power minus 1. Is it correct? No. This number is my 2.7. This is my 0.5, which is not satisfied. This option is cancelled out. Similarly, look about this option. What is the f of 1 by? This is e raised to power 1 by n. This is 2 by n. So I can simply take n is 1. Again, it is my for all n. So it is 1 over 1, e 2 over 1. So this is my 2.718, which is not satisfied. Option also cancelled. A is my correct option of this example. Okay, look at this one. F is my open disk, D is my holomorphic function, f of 0 is my 0, f dash of 0 is my 0. What are the possible value of this? Can you think about what is that? That means 0 is, or you can say f of z has 0 of order. So they have the 2 times. So what is the f double dash of 0? It is not given. It may 0 or may not 0. So you can say it is at least 2, because it's a 2 times, it's at least of the 0, 2. Then whenever you have to find the initial point is given to you, corresponding the same derivative is given at the same point, we always use the Schwarz inequality. What is that? This is always be less than of, if I say this is the nth, this is my n factorial, and this is always be less than of here. Now you can see the derivative here, but we need a value of the f of half. So we can see about here. What is the f of half? This is half of 2, so that is 1 by 4. So look at that. 1 by 4, sorry, it's a less than equal to each case. 1 by 4 is less than equal, is a possible value. Minus 1 by 4, that's also satisfied. 1 by 3, is it less than of the 1 by 4? No. So this is not possible for n is equal to 2. It has a at least 2. What will happen if it is as at least 3? So it is my 1 by 2 raised to power cube, 1 by 8. So you can see again not satisfied. Minus 1 by 3 because it's a modulus value. So again this is not satisfied. Right answer is A and B. Remember, Schwarz inequality is applicable only when you have the function at the point A and the derivative at the point A is given to you. Okay, now you can see here the only value is given to you as a single point. Derivative value is not given. So you can't apply this Schwarz inequality. So once this inequality is not applicable, then you can think about some another way. How you can think about that? Firstly, what is given to you? This is my here, and f of 0 is my iota, possible value of the, so my target is to find what is a function of the fz firstly. Fine. So how you can think about that? Look at that. Firstly, I can check about the modulus value. which is 1, and 1 is my here. What is the meaning of that? It means f has attained 1, that is a greater than, so it means it's a minimum value at z is equal to 0. Fine. So I think you can recall that whenever there is existence of the minimum or maximum, which principle will be applicable? Minimum modulo principle. If you are talking about the maximum, then the maximum modulo principle. What is the minimum maximum modulo principle said? If f attain the minimum value at the point g, whatever the point, if it is point in the domain, then the function will be my constant. That is the meaning of this minimum modulo principle. That is, if f attains minimum or maximum value at the point z0, which is in the domain, then the function will be my constant. Now the function attained the minimum value at the point 0. Is it 0 in the domain? Yes, 0 belongs to the domain. So it attained the minimum value, so function will be my constant. So z of 0 is my alpha. Now what is the value of the alpha? And you can see f of 0 is my iota. So what is the meaning of that? Alpha will be my iota. So what is that? F of z is my. So now what is the possible value of the f of half? F of half will be my iota is the right answer. Fine. So that's a very simple by using the maximum or minimum modulo principle. Okay, the minimum possible value of this. That's a very simple question. That's a very simple. There is no need to think about like of this. There is no need to think about x plus iota y. What is the shortcut tips for you? You can write this. The center is my 0. This is my 0. Center is my 3. 3 comma 0 is here. Center is 0 comma 6 iota. I can written as a 0 comma 6. So 0 comma 6 will be here. Fine. These are my points. Now you can make complete the triangle. This is my triangle. Now we all know the minimum point of this quadratic will be from this point, that is my centroid. So how you can find the centroid? So I call it as a ZC. So coordinate is 0, 6 iota. So 0 plus 3 plus 6 iota divided by 3. So 1 plus 2 iota. Fine, this point is there. Now what is the minimum distance of this? I can find the distance over here. So I can substitute Z at the center. So 1 plus 2 iota square. 1 plus, so it's a 2 iota minus 2 square. And it's a 1 minus 4 iota square. So what is the complex conjugate of this? So it's a 1 plus 4. It's my 4 plus 4. It's my 1 plus 16. I think all of you know how you can find the complex conjugate of this. Absolute value of this is here because it's already square. So what is that? It's a 12, 13. It's a 17. It's my 30 is the right answer of this problem. There is a simple way you can find the centroids. Find the distance between them. You will get as the minimum of here. Okay, f is my entire function which satisfied f square. F dash square is my 1. Consider the two function limit point and here. So look at that. As I told you earlier, f has a constant f for it. So f, what are the various ways you can prove f is a constant? The first is, if you prove that f is entire and bounded, then it's a constant. Otherwise you can prove that the limit point of the set belongs to the domain, then it's a constant by the identity theorem. So now here you can see, firstly x and y has a limit point if x, y and here, that's simple. So look at this. Firstly we think about the y. What is y given to you? F double dash, f is equal to 0. Fine. Can you think about it? Is just like say differential equation, y double dash plus y is equal to 0. So y will be my cos x plus iota sin x, or like here. So it means in this case this or cos of z satisfied. Fine. So what is the meaning of that? You can find the value of the y, which is nothing but my z is a complex number. What is that complex number is? sine of z, because it satisfied this property. Can this y satisfied here? So you can see it's a sine square plus f dash is a cos square. It is also satisfied. So this y is satisfied by here. Now it said it belongs to the opening. It lies between. It's a set 1 comma minus 1, but this value lies between -1 to +1, not only from the -1 to +1. So this option is cancelled. Okay. So now look at that. If y has a limit point, it means the function must be the constant. But you can see f dash is a constant. So what is f dash? If this is my f, what is the f dash? Cos z, which is not constant. Fine. So it means this option is cancelled. If x has a limit point, can you think about any of the function whose derivative will be 0? So like say y dash is 0, so m is 0, that's a single constant. So it means x will consist of the certain constant. So if x has a limit point, then the function is a constant, is a correct statement. Now this is a correct statement if you prove that either x or y will exist as a limit point. Now how you can prove that? That's also very simple. So look at this given statement. What is given to you here? I can differentiate them. 2f f dash is a 2f dash, f double dash is my 0. So 2 will be cancelled out, f dash common, f double dash plus f will be 0. Now remember, f is my entire function. Fine. What is the meaning of that? F dash, f double dash, also the entire function. Fine. F double dash plus f, also the entire function. Fine. Now this is the product of the two entire function is 0. Once the product of the two entire function is 0, it means either of them has a limit point. Either of them has a limit point. Now you can see here, this is my f dash, this is nothing but my x, this is nothing but my y here. So this is the entire function, this is the entire function, product of the two entire function will be 0. This implies either of them has a limit point. It means either x has a limit point or y has a limit point. So the first option is the correct option. But we already proved that y does not has a limit point because of this property, f is here, so this option is cancelled. If x has a limit point, it means this f must be a constant, and we already proved that what is the nature of the f? It's a constant. So this is also the right answer. So A and C are my correct options. Okay, now look at this case. Here the point function value is given to you, but the derivative value is not given to you. Fine. So then what you can think about that? You can simply remember this formula always. Whenever you want to find the derivative value at the point of z, which is always be less than or equal to value of this divided by 1 minus here. That's a simple formula you can simply remember. You can see half. Is it f of half given? Yes. Then you can simply compute them. What is that? It is less than of, what is the f of half? 0. 1 minus 1 by 4. So it is 3 by 4, 4 by 3. Fine. So first property satisfied. F dash 0. So f of 0 is given? Yes. So you can find also what is the f of 0? F of 0 is my 0. 1 minus 0. So it is my 1. So less than equal to 1 satisfied. F dash 0 is less than 1 already satisfied, and f dash is, this is a repetition of this first and second clear. F of z is equal to z, which is not true, because you can see f of half is half, which is not equal to 0. So this option is cancelled. So remember, this is a simple shortcut formula for you to find the derivative values. Again, this is the same case for you. So I can use again this formula. Remember, this is less than or equal to 1 minus of this divided by of here. So what is that? 0. Remember, this 0 and lies in this. So what is the f dash of 0 modulus? What is f of 0? Half. So numerator is 1 minus 1 by 4, 1 minus 0. So it is 3 by 4. Less than equal to 3 by 4 satisfied. F dash of half. This is 1 minus 1 by 4. What is the f of half? 0. So 1 minus 0 is my 4 by 3. Satisfied. These are the same. Again, this is not satisfied because f of 0 is my half, which is not 0. Moreover, this is also not satisfied. Okay, look at that. F of 0 is given to you, f dash 0 is given to you. So we can again apply this formula. Moreover, you can apply the Schwarz inequality as well. Fine. But there is no need of this because you have to prove that there exists or not. So firstly, we will apply this formula for f dash 0 is less than 1 minus f of 0 square, 1 minus 0 square. So this value is 2 less than equal to 1 minus 0 over 1, which is not possible. There exists, cancel out. Look at the other option. This is the f 3 by 4. This is the f dash 2 by 3, which is not given to you at the same point. 3 by 4. This is, you can apply them because they are same on this point. So f dash 3 by 4 is less than equal to 1 minus f of 3 by 4, 1 minus 3 by 4 whole square. So left hand side will be f dash modulus of this. So it's my 3 by 4. F of 3 is a square. It's a 9 by 16 and 1 minus 9 by 16. This is 1. So but 3 by 4 is less than 1. Yes. So this there exists to them is the right answer of this problem. Fine. Now look at this f of 1 by 2, f dash 1 by 4, which are not at the same point B. So look at this second option. How you can check about the second and 4? So that's very simple. If I simply take this is my here. Fine. Then what is the f dash? Is my a. So if I think about here, what is the f dash of z is my a. So what is my a? A is my 3 by 4. If I take a is my 3 by 4, if I substitute here for this point, left hand side is 3 by 4, a is my 3 by 4, z is my 3 by 4 and b is my here. So what is my b? 3 by 16. So what is the f? 3 by 4z plus 3 over 16. Now we have to check about the domain. We can take the modulus. This is less than of 3 by 4 modulus z plus 3 by 16. On this z is less than 1. So it is less than 3 by 4 plus 3 by 16. What is that? It's my 15 over 16, which is still less than of the 1. So it's satisfied here. So it means this option is also correct one. Look at the last option. Again, if I consider function as a az plus b, what is the f dash is my a. So what is that? F dash of 1 by 4 is 1. So a will be my 1. If I substitute here at this point, left hand side is my minus half, a is my 1, z is my half, b is my here. So b will be my minus 1. So what is the function is there? Z minus 1. So if I take the modulus, it will be less than or equal to this plus 1. Z is my less than 1 plus 1, which is less than of the 2, which is not satisfied because this value can be the 1.5 as well, but the function is not satisfied over this f of z 1.5. So the right answer is B and C are my correct option. Remember, because same initial point is given to you, so you can apply this formula. Same initial point is given to you, so you can apply this formula as well. Okay, look at this question. P is a polynomial in the one complex variable. P is a polynomial in the one complex variable. So you can take any value, say z minus iota. You can take z plus iota as well as on your choice. Then h is considered as here. Then which of the following is there? Fine. What is the derivative? 1, because we need here. So look at the first portion. Imaginary, okay, firstly we will find the what is the p dash over p. P dash is 1, z minus iota. So this is x plus y minus 1. So if I rationalize them, this is my x squared plus y minus 1 whole square. Now for the first option, z is my real number. What is the meaning of that? Imaginary component will be 0, that is y will be my 0. So what is my p dash over p? For the first part, y will be 0, so this is my p dash over p will be my x plus iota over x square plus 1. Fine. So imaginary part, what is the imaginary part of p dash over p? 1 over x square plus 1, which is always be a greater than 0. So this option is satisfied. Look at the second option, when z is r, so that's the same case, y is equal to 0, then the real component of, what is the second component is? Real component of iota times p dash by p. So this is my p dash by p. When you multiply this by iota, so this is my iota, this is my minus 1. What is the real component of this? Minus 1 over x square plus 1, which is always less than 0 for all z in the real because of the scale. So this is also satisfied. Imaginary part of the y dash over y, when imaginary part of z, that is y is less than 0, z is the complex number. Now in this case y is not a 0, so this is my p dash by p. Fine. Take about the imaginary part. So imaginary part of the p dash by p minus y minus 1 over x square plus y minus 1 whole square. Now you can see y is my less than 0, so you can take minus 1. It is my minus of 2 is the plus of 2. This is always greater than 0. So whenever y is negative, so y minus 1 is also less than 0, so it is always positive. It's the right answer. Look at this one, when imaginary part is greater than 0. So look at this case. When y is positive, is it always positive? So it depending upon that. Whenever y is my greater than 1, denominator is always positive. When y is my greater than 1, this number will be less than 0. When y is my lies between 0 and 1, this number is my greater than 0. But he said 0 for all the z. It is wrong option. So correct answers are A, B and C are the correct answers. Okay, look at this function which is given to you as this 1 minus omega z here. Then which of the following is my 1 1 onto 1 1 onto? How you prove the 1 1? So that's a very simple. You can start from here and then prove that this is my here. This is my 1 1 property. Similarly for here. But if I prove that it's a bijective, firstly we will check about whether it's a bijective or not. If it is a bijective, then 1 1 onto. So we all know if f is the any mapping, then when it's a bijective, when f circle f is my identity, then it will be the bijective map. Fine. So in this case we will check about the f of f z. If I prove that this is my z, then it is my identity. So we can see about it. What is the f of z? This is my here. Fine. Now again apply on this. So omega minus 1 minus of this divided by 1 minus of z. 1 minus of this. Now take the LCM. This will be cancelled out. So it will be omega minus omega omega bar of z minus omega plus of z. And for this case 1 minus omega bar this, omega into omega plus omega of this. Fine. Now you can see about here. This will be cancelled out. This will be cancelled out. In the numerator case z will be common. 1 minus omega bar. Denominator will be my here. So what is that? This is z. So what is the meaning of that? F circle f is my z is proof. So it means it is a bijective. Bijective means it's a 1 1 as well as onto both. So f is onto correct option, f is 1 1 correct option. So second and the fourth are the wrong. A and C are my correct options. Okay, f is the mapping defined like of here. Then which of the following statement is true? What is given to you in the statement? What is the first part is? A range set. You can see this is a range set. This also this is the part range set of this. Okay, phi of this is a range set. Phi is onto, again we need a range set. This is the range set. So we firstly find the range set. How you can find that? If I simply take off this, I can find the value of the z from here. So what is that? I can multiply this 1 plus z. So I can take the value of this as z is outside 1 plus 5. Fine. 1 plus z. 5 minus 5z is 1 plus z. So it will be here. So what is the meaning of that? Z will be my 5 minus 1 over 5 plus 1. So what is the meaning of that? This z defined for all the values of the z except whenever this phi of z is my minus 1. When phi is my minus 1, then you are unable to, whenever phi of z is my minus of 1, then you can never back to that. That is, this is a not on to. You are unable to find the value of the z whenever phi of z is my minus 1. So what is the range set? What is my range set? Complete except the minus 1. So you can see this is a complete range set. This is z less than 1, but it is mode of them. It's open intervals. It does not include the minus 1. Range set less than real component of the z, but we need a minus 1 for all the z. It's cancelled. It is not a onto. You can see phi of this is my c minus of 0 1. This is a range set. Right answer is my D is the correct option. Okay, look at this option. So what is given to you? E of Ez is my 1. Then for which of the following is 2? That's a very, very simple question. We all know e raised to power z is 1 when z is my iota y. Fine, because e raised to power iota x, I can written this as cos x plus iota sin x. So if you take the modulus, it will be 1. So that means it's a purely imaginary part. Fine. So my target is to take this number as a purely imaginary. How you can take the purely imaginary? So you can see I can take e raised to power x of here. Fine. Now how you can think about that? So z is my here, so y will be my, y is my real number, then it will be the purely imaginary, because if it is y is my imaginary, then it's my real. So y will be a real number. So it means this part is must be my here. So this portion must be by, what is that? This portion must be by 0, or sorry, this part will be my, must be 1, because if this is my 1, then it is my real. So 1 I substitute here, it will be my 1. So e raised to power iota y will be 1 when you can see cos y plus iota sin y is 1. So it means sin y, sorry, cos y will be my 1. When the cos y will be 1, it at the 0, or you can see at the point of here. So 2n plus 1 pi by 2 is the right answer of this simple problem. So remember, this is there, you have to think about that. This is must be the form of the iota times real component. Fine, then only it will be the 1. So that will be the real. So how you can make them this as a real? When only it is of the e raised to power x. So this part must be the 1. When it will be the 1, if you open them, if you compare, cos is my 1. So when the cos will be 1, it's a pi by 2. So it's a pi by 2 and here. So this is the right answer of this problem. F is the entire function. F is my here. Okay, f is my entire function is given to you. Then real part of the f is my bounded. That is, if I consider f is my u plus iota v, this is my bounded. So as I mentioned you in the previous, how you can prove that a function is constant? As I proved, given that if you prove that f is my entire plus either u or v, that is a real or imaginary parts are my bounded, then you can prove that then it's a constant. Otherwise, second is if you prove that the limit point of the function is in the domain, then it's a constant by the identity theorem. But here u is my bounded, so either is my bounded, so it means f is my constant. So this is my correct option. This is the part B. So imaginary part of f is a constant. Once f is my constant, so what is the meaning of that? When the complex number is said to be constant, when u is a constant, v is a constant, both must be constant. So it means v is also a constant. So once v is a constant, so imaginary part of this is also constant. F is identically 0. That is not true, because this is also my constant. 3 plus iota, this is also a constant, but it is not identically 0. F is a non-constant, that is non-zero constant. That is not true, because f3 is a constant, satisfy this property. F is the entire function, then which of the following statement is my correct? So you can think about that again. Which of the following statement is my correct? F is entire. Firstly, okay, look at the one by one. First option, f is constant, so this is your target. So again, your target entire, it is given to you. If you prove that either the u or v are my bounded, then it's a constant, otherwise limit point. Okay, range set, if I say any set to the C, what is the range set is? F of D is contain a straight line. Okay, this is my complex plane. If you consider any of the straight line here, this is my straight line, so that is my y is equal to x. So how many points on this line? These are my infinitely many points. Fine. So first you can remember the text. Remember, now they are talking about the range. So a range of non-constant entire function is at most, or you can see is skip at most 1 point. Okay, meaning is that if I say range is my f of this is either the complete complex or it skip only the 1 point, like say z1. So but here if I take any of the line, how many points from the complete C it can skip? It skip 2, 2, it skip 3, 3, minus 2, and so all those points are there. How many points are there? Infinitely many points. It means the function is my non-constant. So this is a constant function, it's my option is cancelled. If f is constant, if f is uncountably many zeros, can you think about any of the function which has uncountably many zeros? Every point has a 0, so it has uncountably many 0. What is that? This is a constant function, so that is the correct option is there. F is constant if f is bounded on this. What is that? F is bounded, so we have to think about here. F is bounded on real component of the z such that real of u is my less than of the 0. Okay, u is real of this. That is not be true. You can consider any of the example like of this. So if I consider this is e of u plus e of iv, so how you can prove that it's a constant? F is bounded. So if I take the modulus of this, what is that? E raised to power this. So now a real component is my less than 0. So what is that? When you take as a, this will goes to the 0, because it's a less than 0, that's a infinity. So what is the meaning of that? F is the condition is satisfied. So but I have taken this is my non-constant function. Fine. So it means this option is wrong, because he said it's a constant component. What is the fourth is f is constant if real component of the f is bounded. That's a statement of there. That's the same statement I have taken. A real component of the f, that's a u, is my bounded. So that's the same concept about here. Real component of the f is bounded, then its entire also bounded also. So this is also the correct option. So B and D are my correct answers. Okay, f is the entire function again given. Again you have to prove a constant. So if I prove u and v are my bounded, then it's a constant. Look at that. F of z is my u plus iota v. imaginary part is my greater than equal to 0. Fine. So I can simply take v as a 0. So once v as a 0, what is the v of x? 0. V of y is 0. F is my entire function. So by the CR equation, this value will be my u of y is 0. This value will be my u of x is 0. Fine. If u of y is 0, if I integrate them, u is my constant or a function of the x. Fine. Now from this case, this is my constant or a function of the y. But you can see both the partial derivative 0, then it means if u is a function of the x, partial derivative may not be 0. No, not always 0. So it means u is not a function of the x. Similarly, if u is a function of the y, then from here it will not be a 0. So it means u must be my constant. Fine. So now if u is a constant, that's a real component is my constant. Every constant function is my bounded. Fine. So if u is my bounded or v is my bounded, any one of them is bounded, so f is my here constant. F is identically 0, that's not true, because constant may be the 7, constant may be my minus of 8. So this is cancel out. F is a non-zero constant, this is again cancel. A and B are my correct option of this example. Okay, look at this another example. F is given to you as the entire function such that f is given to you as the entire function such that f approaches here. This is my infinity. What is the meaning of that? A function has infinity value, that means has a pole as a singularity. If it is infinity, it means it has a pole as a singularity at infinity. Fine. Or you can also written this number as z approaches infinity. F of z is my fine. So what is the meaning of that? F is my entire function plus, second thing you have to prove that f is my entire function, and what you prove, this is my pole. F is, that means singularity at infinity is my pole. These two things you have proved that. So what is the result of them? Whenever these two results prove, it means the function is always polynomial. So remember this tips always. Whenever there is a function is entire and the only singularity at infinity is my pole, then function is always polynomial. So it means the function is my a plus bz plus c z square and so on. So f is a constant. Every constant function is a polynomial. That's a correct statement. F can be infinitely many zeros. That's wrong, because polynomial always have a finitely many zeros. F is necessary, nowhere vanishes. That's wrong, because if I simply take 1 minus z is a polynomial, so it vanishes at z is equal to 1. So it means this option is cancelled. A and C are my correct options. Every constant function is a polynomial as well, because if I take, this is my 1. Okay, look at this year 2019. What is given to you? F is a considered as an entire function such that f dash of z is less than equal to f of z. Fine. Now look at that. F is my entire function. We need a f dash. This is also my entire function. Fine. Now if I take this as f dash over f, which is less than equal to 1, so f dash over f is my entire function. Fine. From here we prove that f dash over f is my bounded. Now look at that. F dash over f is bounded. F dash over f is my entire. What is the meaning of that? F dash over f is my constant. Fine. So once it's a constant, I call this constant as say my alpha, as it is mentioned here. So what is the meaning of that? F dash over f is my alpha. So can you find the value of the alpha from here? You can integrate them. So it is my f is another constant, beta of this, where this is my complex number. Fine. Alpha is also in this here. Now since alpha and beta is in the C and it has how many values? Infinitely many values. So this f has infinitely many functions are there. So if f is my small f is my infinitely many function, capital F is my infinitely many sets. So S is a finite, is a cancel out. Now you can think about here whether this alpha, whatever this alpha is a constant, is a less than 1 or not. So we can substitute this value in here. What is that? So mod of f dash, this is my f dash, is less than equal to f. Fine. So what is do? I can return this is outside of here. This is less than of this number. So what is that? Because this implies mod of alpha is less than equal to 1. So it means this option is satisfied, this option is cancelled. So the right answers are B and D are my correct option of this problem. Okay, next one is f is my entire function. It is given to you. F is my here, then f is constant. Again, when it will be the constant, if you prove limit point, or you can prove either u or v are my bounded. Fine, either of them. So look at that. U, what is the u? Is my real component, is the bounded. It means it's a constant. V, fine. Sum of the two bounded function is a bounded, so it is also the bounded. It means it is also. It means what is that? F is u plus v is bounded. It means f is my bounded. F is bounded. F is my entire. So it means it is a constant. Now u square plus v square is bounded. U square plus v square is my bounded. This is given to you. Fine. Then f is a constant. So how you can think about that? I can take the derivative with respect to x. I will check about that whether it is here. Okay. And with respect to y, here, this is v, y is equal to 0. Fine. So from here you can easily see u over v is my minus, it is my minus of vx over ux, and from here u over v is my minus vy over uy. Is it fine? Now what is the meaning of that? Both are same. So once both are same, it means vx over ux is vy over uy. So what is the meaning of that? Can you say about anything? What you can say about that? Both are say constant, say k. So u of x is my k times v of x, u of y is my k times v of y. So what can you say about that? How you can say it is a constant? So when f will be the constant? When you prove u is my constant and v is my constant. So how you can prove that? How you can say? That's simple. I can substitute this value here. So what is that? If you substitute here u over v, that is simple. You can simplify them. You will get as if ux is 0. Once ux is 0, what is the meaning of that? U is my constant. Similarly, if you substitute here, you can simply solve this. You can simply solve this equation like of this, like of 2ux plus 2vy. If I consider this as a y, this as a x, and here, then you can easily see this value will be my 0. So this value is nothing but my u of y. So both are constant. So once u is my constant, here v is again a constant by the CR equation because of the entire. So this is also be a bounded. So once is a bounded, then the function is constant as well. Okay, look at this 2022 function is given to you here. Then you have to find the derivative of this f, a1, a2, an. You know what is the an? Once you know this is the function, then you can easily find at the center. Center is given as a 0 over n factorial. This is my an. Fine. Now firstly you can find the first derivative. First derivative will give you the a1 as well. Fine. So what is the a1 at the point z? So 1 minus z, firstly we can take this, I can written this as z plus here plus 1 minus z e raised to power of this same and 1 plus of z. So I can take e raised to power z plus z square by 2 common, minus 1 plus 1 minus z square. So it is my minus z square e raised to power. I written this as a because I have to return again and again. So you can see this satisfied. Fine. So now what is the a1? If you want find the value of the a1, then we have to take 0 over 1 factorial. What is the value at 0? It is a 0 raised to power 0 is 0. This is 0. So 0 square e raised to power 0 is my 0. a1 will be 0. What is the a2? Now I can differentiate this, minus 2z e raised to power a plus z square e raised to power a of, what is the derivative of a is 1 plus z. So I can take z is common, e raised to power a common. What is that? It is my 2 plus 1 plus z plus of the z square. Now what is the a2? This is my second derivative, then second derivative at the point 0 over 2 factorial. This is my a2. So what is the a2 will be second derivative at the point 0 will be 0. a1 is 0, a2 is 0, both are same. Now an. So you can see a2 will be my minus z e raised to power here. This is 2 plus z square, and this is my a1. So e raised to power a is common, z time here. Because of this negative, if you find the a3, it will be minus of this, which is less than 0, which is less than or equal to 0, which is here. Fine. Now since only one correct option, one option is false, so this is the, sorry, which of the following option is false? This is my correct option, this is my correct option, this is my correct option. So right answer is my false option is there. So that is the last option is my correct answer of this example. Okay, look at this is my bilinear mapping. Okay, so remember, whenever you have this mapping A, B, C and D such that AD minus BC is my non-zero. Okay, look at the Mobius transformation over here. Then upper half, then the upper half will map to the upper half, lower half will map to the lower half. So we can check about here. So this is 2 times 3, 1 times 5, which is non-zero. So this is a simple bilinear transformation is there. Then the upper half, that is a H positive map to the H positive, H negative map to the H negative, L positive map to the L positive, and so on. H positive map H positive, H negative map here. H positive, H negative cancel. H positive must be there, but it's a negative are there, so that's a cancel out. H positive, L negative cancel out, because what is the H positive? Y is greater than 0, that is my first quadrant. But what is the L positive? X is greater than 0, so it consists of first and the fourth both, which are not the same map. So that's why this will not map to be here. So only the right answer is my A. Again, this is similar of this. My transformation is, so I can written this as 1 plus 0. So my A minus 0 into 3, which is non-zero. So H positive will map to the H positive, rest all options are. H negative will map to the H negative, rest are cancelled. Okay, given the real number A, which is my positive, consider the triangle. Vertices are my 0. A is my positive, A plus iota A, that is the A comma A. This is my here. So this is my triangle, A comma iota A. If triangle is given in the counterclockwise orientation, then the contour, this real part of the Z of this is equal to, very simple. There is no need to think about that. First method, you can think what is the real component of X is here. This is my here, if I call this is OAB, then you have to integrate this, you have to break from the OA, then AB, then BO, but there is no need. Sorry, anti-clockwise, firstly OB, then BA, then AO. There is no need of that. What is the shortcut tips for you? Look at this diagram. You have to find this area. What is that? This is a right angle triangle. So what is the area of the right triangle? Half base OA, attitude is AB. That's over. What is the OA? A. Height is my iota A. So the answer is iota A square by 2 is the right answer of this problem. There is no need to integrate like of from O to B, then from B to A, and then from A to O. There is no need of that. It's a simple area. You can find it as simple. Okay, now look at that. This is the integration over the anti-clockwise direction. Okay, fine. So I can return this number as 1 plus z square, because it's a modulus, so I can return as complex conjugate of this. Fine, because we all knows what is the property of this is my here. It's a unit circle. So what is the z is there? This is e raised to power iota. Radius is my 1. So I can substitute here. This is my, so it is 1. Or firstly I can open this bracket so that it will be easy. This, or otherwise that's also fine. If I just write here firstly e raised to power iota, e raised to power 2 iota. Fine. I have written 1 plus 2 pi iota outside. This is e raised to power minus plus e raised to power minus of here. What is the dz? It is iota times e raised to power of this. Fine. Now what you can do, if I look at that, if I just multiply here this part, I have written this as such. This iota I have cancelled out with the help of 2 pi iota. So 1 over 2 pi is outside. This I have multiplied e raised to power iota. This is plus 1 e raised to power minus of iota. Fine. Now once you integrate this over the limit circle, here this value will be my 1. Why? Because you can see this value will be my here. So it is e raised to power 2 pi iota is always 1, e raised to power 0 is 1. So sorry, this value will be my 0. 1 minus 1 is my 0. So now you can see first value, if I this and this, if I integrate them over the term 0 pi, the answer will be 0. If I integrate this, the answer will be 2 pi. If I integrate this e raised to power minus iota, this is again 0. If I integrate this, it will be e raised to power 2 iota. Again, if you integrate them, it will be from 0 to 2 pi, again 0. When you multiply this, again 0. When you multiply this, it will be 1. So 1 will be my 2 pi. When you multiply this, it will be my 3, again 0. When you multiply this, again 0. When you multiply this, again 0. So what is the answer of this? 4 pi over 2 pi. 2 is the right answer. There is no need to integrate them. Just think about this here, because we all know e raised to power 2 pi iota minus e raised to power 0 over this. E raised to power 2 pi iota is my 1. 1 minus 1 is 0. So you can simply integrate in a very simple manner. Okay, Z1 and Z2 are the distinct complex numbers such that this property holds. Can you think about any of the function whose modulus will be 1? I can take an as a Z. Fine. This as a 1. Fine. Second is I can take an about here. This is also true, because if I consider here both are my distinct, the modulus, both of the modulus are my 1. Is it the Z1 plus Z2 is my 1? No. So this is not true. So what I can think about that? I have to think one function. If I think about here, half and half, it will be 1. Fine. So I have to take some term here so that it will be cancelled out. So think about 1 by 2. Think about the unit circle. So I can take, this is of here, this is my iota root times 2. Fine. So this is my Z1, this is my Z2, and clearly says that mod of Z1 is my 1, mod of Z2 is also 1. So these two are they simply satisfied. So what are the coordinates of the Z1? Half root 3 by 2. Coordinates of the Z2, half minus root 3 by 2. Fine. And then it form a triangle. So we can make a triangle with the Z1. So I can written say half comma minus root 3 by 2, half comma plus root 3 by 2, and minus 1. The coordinate of minus 1 is imaginary part is my 0. Then it's a equalator, right triangle, and so on. Or if you want to draw it in a proper manner, minus 1 comma 0 is my here. Sorry, minus 1. X is my minus 1. This is my minus 1 comma 0. Half is positive. This is my second minus root by 3 here. Half is positive here. So these are my triangle of this component. Fine. Say A, B, and my C. Then now you can see the statement. It is given to you whether it's equilateral triangle, isosceles, and here. So you have to find the length of the AB. Fine. So this is my C. This is my C, and these are the positive. This is my A. This is my B. What is the distance of the AB? You can find the distance formula. So it is this minus this plus this minus this whole scale. That is the distance formula. So it will be my 9 by 4 plus 3 by 4. So it is my root 3. So this value will be my root 3. You can see what is the distance of this. This is a perpendicular line. So the distance will be root 3 again. Because it's my root 3 by 2. It is my minus root 3 by 2. So total distance will be my root 3. What is the AC? It is my minus 1 and it is my half. So it is minus 3 by 2 whole square plus root 3 by 2 whole square. So again it is 9 by 4 plus 3 by 4. It is my root 3. So all the sides are same. So it is a equalator. Right angle not be there because it's equalator. So each angles are my 60 degree. Isosceles but not necessary cancel. Obtuse angle cancel because all have the 60 degree angles. Okay, you have to find the pole. What is the rule for the pole? You have to put the denominator as a 0. But make sure if you put denominator as a 0, what is that? This is my n. N is my positive natural numbers. But at this point, numerator value must be a non-zero. But you can see when you take z is my 2. Okay, I can write for you here. This is my pole. So it means pi of z is my n pi. So what is that? Pi will be cancelled out. So the poles are my here. Fine. But at the same time, we have to also check numerator value will be non-zero. But if I take n is my even numbers, then clearly say this will be my 0. So it means even numbers are not my pole. So all the even numbers are pole, cancel out. All integer cancel out. All the odd numbers are my pole. That's the correct option. So what is the odd is 2k plus 1. All the integers of the form of this. So I can return this 4 as of this. I can return this number as of this also, plus 2 minus 1. So this is my odd. You can see 2 times of odd minus 1 is also be a odd number. So it is also of this form. Fine. But there is one second method also. There is no need of think about that. Look at this function. This is sine pi z over 2. If I open this formula, denominator formula, sine of a is 2 sine a by 2 cos a by 2. So 2 sine pi z by 2 cos pi z by 2. So what is 1 by 2 cos. Now since numerator is a constant value, so how you can find the pole? Simply you can take pi z by 2 as a 0. So when it will be the 0? When it will be 2 and 1 pi by 2 as the here. So what is the meaning of that? Pi by 2 will be cancelled out. So z will be my 2 and plus 1 is the. So that's my only odd number. So this is odd, this is odd is the right answer of this problem. Okay, consider the function f from 1 to 2 x minus z whole square of dx. There is a meromorphic function g that agree with the f. Fine, that agree with the f, that means this is same. So I integrate this with respect to the x. So minus 1, minus 1. Fine. So what is that? This is when you substitute 1, it is 1 minus z, and when you substitute 2 is here. So if I simplify them, you will get as here. Fine. Now that's a pole array. So how now you can see the numerator is my constant, so poles are my 1 and 2. So 1 and 2 are pole. 1 and infinity pole cancel, 0 1 infinity pole cancel. 1 and 2 are the simple form because all have the degree 1, so it has also the simple pole. So both are the correct answers. Okay, now they are talking about the zeros. Okay, how you can check about what is the meaning of that? If f has order 2 at 0, what is the meaning of that? It means f of this is 0, f dash 0, f double dash 0, but f triple dash is non-zero. That's the meaning of the order here. But what is the meaning of this order? So if I take this as a 0, what is the meaning of that? Z square 1 minus cos z is 0. Fine. So here if I open this as a series, it will be z square by 2 minus z4 by 4 factorial and so on. Fine. If I take z square as a common, now you can see 1 over 2 factorial, z square by 2 factorial and so on is a 0. So clearly say that z is equal to 0 are of the order 4. So the third option is the correct option. Now they are talking about the 2 and pi also. So we all get as a 0 as of 4. Now I can return this number as a 0. Cos z is my 0. Sorry, cos z is my 1. So when the cos z will be 1, when z will be my 2 and pi. Fine. Now 2 and pi is of the order 1 or 2. So that I can check it. This is my 1 minus cos z. Fine. So since it is of the here, this is a non-zero for all 2 and pi. So I can simply take here. What is f dash is plus sin z. Fine. F double dash cos z. If it is order 1, then this value will be 0. Otherwise here. So you can see f of 2 and pi 0. F dash 2 and pi sin 2 and pi 0. F double dash 2 and pi cos 2 and pi is 1, which is a non-zero. So what is that? This is of order 2. So fourth is the correct option, first is the cancel out. So third and fourth are my correct option of this problem. Okay, look at this. Here you have to find the removable pole essential RT. That's a very simple. This is the simple tips for you. If you have always a function of the complex rational function, if you find the zeros of the p, that is the numerator, if it's come to be alpha, beta, these are the rules. So if I think about here, they are talking about the 0. So f of 0 is 0. What is the f dash of z cos z? Is it 0? No. So what is the meaning of that? F has 0 of order 1. Fine. Now if I take the denominator, say g is 1 minus cos z. So g of 0, cos 0 is 1, so it is 1 minus 1, 0. Derivative sin z. Derivative 0. G double dash is my cos z, which is non-zero. So it means g has order 2. Fine. But here this is the power m. So it means if I consider this as a pz is sin z of m. So what is the order of this? What is the order of the sin z? 1. So this is a 1 into m. That is a m. If I consider q as my 1 minus cos z raised to power n, this has order 2. So what is the order of this? 2n. So that is alpha is my m, beta is my 2n. So pole when 2n is greater than, strictly greater than n, 2n strictly greater than n is a pole. Fine, that's the correct statement. removable singularity when 2n or beta, that's 2n is less than or equal to m. So m is greater than or equal to m is a removable singularity. That's a cancel. This is my here. Essential is not be there, so the right answers are A and B are the correct options. Okay, they are talking about the number of the zeros. So how you can find that? I can take this as a 0, e raised to power 1 plus, this is my 1. I can written this as 2 and pi iota in terms of the complex number. So what is that? Z plus iota is 2 and pi iota. So this is 2 and pi iota minus of this, where n is my natural number. So s has finitely many zero cancel because this is infinite. Z is my infinite, so it is my infinite. R is a sequence that has a removable, is converges to a pole, it converges to here. How you can prove that? You can find the limit point of the z as n approaches infinity. This is my minus of iota. So once you are finding the limit point of this as minus of infinity, what is the meaning of that? How you can say it is? So limit point of the limit point is my here for n is my infinity. So remember, limit point of the zeros will corresponding to the isolated essential singularities. Fine. So what is the meaning of that? These are the limit point of the zero. Limit point of the zero corresponding to the essential singularity. So converges to the essential singularity is the right answer. Converges to pole, wrong. Converges to the removable singularity, or wrong. So the right answer is my only D is the correct option of this example. Okay, look at this example. H is given to you as the upper half space, and H is given to you upper half space in the open disk. F is my Mobius transformation. F is given to you as a Mobius transformation. Then F is a map H onto D. This is given to you. Fine. So H is my upper half space and D is my open unit disk. So what kind of the function is there? What kind of the function is always exists in this case? This is always of this nature, z minus beta divided by z minus, where now thing is unknown number is beta, where beta is the root of f of z. Fine. So beta is the root of the f of z. Now you can see here, what is the meaning of that? Beta is my 2 iota. So if I substitute here of this z minus of 2 iota, z minus minus plus of 2 iota. Fine. Now this is my function of the z. Clear? Where theta is belongs to the real number. This theta is real number. Now you can check about that. F has a simple pole. How you can check about the simple pole? So you can see, you can put as a denominator 0. When you put denominator as a 0, you will get as of this. So but make sure at this point numerator should be non-zero. You can see the numerator is a non-zero. So yes, it is my simple pole. So first option is satisfied. Look at the second option. What is the f of iota? You can see e raised to power here. This is minus iota. The denominator will be 3 iota. This is minus 1 over 3 e raised to power of this. What is the f of minus iota? It is here. If it is minus iota, it is my minus of 3 over plus of iota. It is minus 3 e raised to power of this. Now you can to take the complex conjugate of this. What is the complex conjugate of this? It's a minus 3 of this. Now you can multiply them. Once you multiply them, it's a minus minus plus, it's a plus 1. It's a plus 1. Satisfied. F is the essential singularity at z is equal to 2 iota. How you can prove that it's an essential singularity? Now, firstly I will check about this part. Fourth option, if I substitute here, f of 2 plus 2 iota, it is e raised to power iota theta. 2 plus 2 iota, so numerator will be 2. 2 plus, it's a 4 plus 4 iota. Fine. Now you have to take the modulus value. So this value will be 1, its value will be 1 over 2 plus 2 iota. Fine. 2 plus 2 iota, it's a 2 plus 2 iota, yes, it's a here. So what is the modulus of this? It is my 4 plus 4, 1 over root 8. So this is not the correct answer. So this is my here. So 2 plus 2 iota. So it is, sorry, it is 2 plus 2 iota. It is my 2. So it is 2, it means it is my 1. It is 1 means it is 1. It is my 5. So it is 5 means this is my correct option. Fine. Now, f is essential singularity at z is equal to minus iota. So now here you already proved that z is equal to minus iota is my pole. So once it is a pole, what is the meaning of that? If you simply take, if it is a pole, it means it does not have a essential singularity at same point, z is minus iota, because it is already a pole. So this option is cancelled out. Right options are A, C, B and D are the correct options. Now look at this again, the next option, which is related to the pole at the point z is equal to 0. So firstly, if you take z is equal to 0, it is 0 by 0 form. So it means if you take about here, it is my 0 by 0. So you can take the L'Hopital rule, 1 over sine z. So once it's a 1 over sine z, now it is not in 0 by 0 form. So what will happen if you consider limit z approaches 0, it's a 0, it goes to the infinity. So once it goes to the infinity, it means limit does not exist. So once the limit does not exist, it means it is my essential singularity. So it is a pole node, it's a removable node, it's a essential singularity. And once we know it's essential singularity, then in the Lorentz series we have the infinite number of the terms. How many terms? Infinite number of the negative terms of the 1 by z. Okay, that is the in the principal part component of the 1 by z, but he said many positive as well as negative both. So right answer is only C is the correct answer. Again you can see at z is equal to 0, at z is equal to 0, the numerator is my finite, denominator is my 0, so that is my pole is the right answer. Removable node, essential node. How you can find the residue? So we can see I can multiply this by z over here. Now it's a 0 by 0 form. You can apply the L'Hopital rule. So this is z plus 1 of e raised to power z. Now you can see this is my z plus 1. So once it is my z plus 1, can you say it is an essential? Can you say it is my, how you can say this is my, this is z of this. So this is my here. Fine. Now it's a 0 by 0 form. So if I take that derivative, it will be my here over this. It is not cancelled. Now it's at the 0. It is my 0 plus 1 over 1. That is my 2. That is my residue. So residue is my 2 is the correct option. Right answers are B and D are the right answer. Now you have to find the residue. So what is the residue again? So at the point 0. So you have to multiply this into z, e of this. So I can return this number as of this manner. Fine. But you can see it is my 0 by 0 form. No, it's e raised to power 0 infinity. It's a multiplies 0. So I can simply take as the expansion form. So what is the e raised to power z expansion? 1 plus 1 by z square. 1 plus 1 by x plus 1 by 2 z square and so on. Now if you take as a negative sign, it will be the negative of this. If I take again the exponential, it will be of this nature. I can return this e raised to power minus 1 is outside because it is written in this form. So it is my of this. Now again I can apply the e raised to power x rule here, x plus x square by 2 and so on. So it is e raised to power minus 1 plus x and so on plus x square by 2 factorial and so on. So how you can find the residue at x z is equal to 0? That is the coefficient of z minus 0. So what is the coefficient of the z minus 0? If you open them, what is the coefficient is e raised to power minus 1. Third is the correct answer of this problem. So look at the next questions. You have to find the radius of the convergence of the Taylor series. So that's a very simple tips for you. As I already mentioned you here in my previous lecture, z of the center minus z at the pole. That's the radius of the convergence. So what is that? Center is my, here you have to find this value, so it is 1. What is the pole? Denominator you can substitute 0 and you can check it's a finite. Yes, it's a finite, so 1 minus 0 is my 1 is the right answer. Find the radius of convergence of this. Now it's note the center is like in the previous case, it is given that you have to find the radius of convergence at the 1 Taylor series, but it is not given. So we have to apply the simple rule are there. So what is the radius of the convergence? 1 over limit an plus 1 over an as n approaches infinity. So what is that? Log of n plus 1 over log n. So it's an infinity by infinity form. So I apply the L'Hopital rule. So now it is a n over n plus 1, which goes to the 1 as n approaches infinity. So it means this is my 1 over 1 is the right answer. P and Q are the two non-constant polynomial of degree m. So P is my degree is my m, Q is my degree of n, polynomial of degree m. So once P is my polynomial of degree m, what is the meaning of that? P has zeros of m. Similarly, Q has zeros of n. Then the product of the multiplicity, so what is the meaning of that? P and Q has the zeros of m plus n. That's a simple straightforward result for you. Okay, F is my U is my bounded opposite. This is my homomorphic. F0 is 0. Composition is there. Which of the following statements are true? Okay, so we will apply the induction. When n is equal to 1, so it will be my F. Composition is F dash, and when n is 1, it is trivially 2. When F is 2, that is a composition. F circle F of derivative at the point 0. You all know how we can derivative them. So it's a g dash of f into f dash. So I can take this f dash of f at the point 0 into f of 0. So you can see what is f of 0 is 0. So this value is 0. This value is 0. This is also f. So it is my square. You can see this is satisfied. N is equal to 1 satisfied, n2 satisfied, and you can see also it's a satisfied. Now again, when n is equal to 1, it is my f of u is a subset of u. That's the correct statement from here. If you take n is equal to 2, then f circle f of u. So I can return this as f of u. F of u is the subset of the u. F of u is the subset of the u. So this is nothing but my f of 2. So this is also the correct statement. Look at this option. The sequence is my bounded. So look at that from here. How you can prove that the sequence is my bounded? That's again a very simple. You can think about of this f dash of 0 of n. Now you can say, okay, how you can think about that? You can apply the this. Okay, I can of this is always be less than or equal to f dash is always be less than of the n factorial. Fine. Now if I take f dash raised to power n, it will be my of this. Fine. F dash of the 0, that's here. Now you can see if you take the modulus of this, and it is clearly be less than of the n. You can see that when you take n approaches infinity, it is always be bounded. Otherwise, if you don't think about here, then you can apply the LR inequality, that is m over r raised to power n plus 1. So here n is my 1, so it is my m over r, which is my bounded. Fine. So this is my sequence is my bounded. And if I take n is my 1, because this number is nothing but my here, if I n is 1, it's a bounded, it's a less than of the 1, is all are my correct option of this example. You can see the last case, you can always remember by this is always, as I mentioned you here, you can see this remark, f of n at the point 0 is my n factorial. So here n is my 1, so it is my 1 factorial is 1 is the right answer. Okay, p is my polynomial of degree greater than or equal to 2. I can simply consider as my polynomial is x square. Then the radius of the convergence of this, so an plus 1 over an, n plus 1 square over n square, which goes to the 1 as n approaches infinity. 1 is the right answer. The power series converges for here. Okay, so firstly the center is my 1, so the first two options are cancelled out, whether it's equality or not. That's a major question. So if I consider z minus 1 is my root 3 equality, so what will my series? 3 raised to power minus n root 3 raised to power 2n. So what is that? If I see, this is nothing but my, this is 3 raised to power n, 3 raised to power minus 1 is a 1. So we can always remember, you can see in my PY question of the real analysis, constant series always divergent except 0. That means if you written as this, then it is a convergent, but if you written this as a alpha can be anything, then it's a divergent. So at this equality it's a divergent, not convergent. Right answer is my here. In this case you can see it is my z, so all are here. Firstly we will check about the point 2. When z is equal to 2, it is my 4, series will be my 2 raised to power n, it is my 4 raised to power n, or 2 raised to power 2n, so it is my 2 raised to power n. This is a GP series. GP series is convergent when the common ratio is less than 1, but here is my 2 which is greater than 1, so this is not convergent. Look at this equality, root 2, so this series is my 2 raised to power minus n, root 2 square, it is my 2 raised to power n, this is my 1, but again it's a constant series except the 0, this is also the divergent. Now look at these two options are there. You can find the radius of convergence. So 2 raised to power minus n. How you can find the radius of convergence? You can take the limit n approaches of 1 by n, 2 minus 1. This is the radius of convergence. So 1 over limit an of this. So 1 over 2 raised to power minus 1 is 2. So what is that? This is my z square. Polynomial is in terms of the z square is less than of the 2. So what is that? Z is my root 2 is the right answer. This is wrong. Equality option you can easily discard. Okay, look at this option. So here center is my 0, radius is 3 by 2, so it is my minus 3 by 2 plus 3 by 2. Now look at that. If I substitute this as a 0, this is my 1, this is my 2 iota. So where is the 1? 1 means 1 comma 0. 1 comma 0 lies here. 2 iota means, what is the modulus of the 2 iota? It is my 0 comma 2, or the center point. It is my 3 by 2. 2 comma 0 lies outside, so there is no need of them. So only z is equal to 1 is the singularity. So I can substitute z is equal to 1 in here. So 2 pi iota times e raised to power this into 1 over 1 minus 2 iota square. So what is the mode of c? So 2 pi iota is there, so this is my c, and I need a mode of this. So the numerator value is my here, and this is 1 minus 4 iota. So what is that? The numerator is 1, denominator is 3 plus 4 iota modulus. So 1 over 5 is the right answer. So again you have to find the integration. So you have to draw the circle. Center is my 1, radius is also 1. So this is my here. This is my 0. This is my 2. Now z cube minus 1. So how I can written that? Z square plus z plus 1. So if I take the factor, this is 1. This is minus 1 by 2 plus root 3 by 2 iota, and minus 1 by 2 minus root 3 by 2 iota. So look at that, which point will lies here? Z is 1, lies here, fine. Minus half, minus half is here, plus that lies outside the circle, there is no need of this, minus half minus root 3 lies outside of this, so only z is equal to 1. So I can skip this portion, I can substitute z is equal to 1 here, so 1 over 2 pi iota 1 over, substitute here 1 plus 1 plus 1, so that is my 1 over 3. I can multiply this by 2 pi iota, so it is cancel out, 1 over 3 is the right answer. Again you have to draw the circle, center is my 1, radius is half, so it is from half to 3 by 2. This is my circle about here. Now you can take the denominator as a 0, it is plus 1 and it is minus 1, so denominator will be z plus 1 z minus 1. Fine. Now at z is equal to 1, this is finite, minus 1 it is also finite. So where is a z is, if I substitute this as a 0, it is minus 1, minus 1 lies outside, so there is no need, z is equal to 1, it lies inside it, so we have to remove this portion, substitute z is equal to 1 here, multiply by the 2 pi iota, so z is equal to 1 e raised to power 1 2, so 2 pi iota will be cancelled out, so answer is e by 2. Why it's happened? It's a pi, so I think there is no 2 pi iota, otherwise it will not be there, so here is a not 2 pi iota, so what is that? This is pi e iota is the, so I think there is a typing error from my side, there is not be there, so it's a pi e iota is the right answer. Again this is the same kind of the question, center is my, I can return this number as z minus 1 is 1 also, center is 1, radius is 1, so it will be from 0 to 2. So look at the function e raised to power z, z minus 1, z plus 1. So if I take this as a 0, z will be 1. If I take this as a 0, z is my minus 1. And at both these points, the numerator is my constant. Z is 1, fine. Minus 1 lies here, so there is no need of this. So I have to substitute z is equal to 1 apart from this case. So what is that? Since 2 pi iota is not be written, so 2 pi iota multiply z is equal to 1, so e over 2, so 2 will be cancelled, I pi of this is the right answer. If both will be there, then you have to multiply first case this plus 2 pi iota, then you have to skip this portion and substitute this in the remaining part. Okay, which of the following set is my correct? R is my any real number here, so that is little bit calculation, I think, z of n minus 1. Okay, that's a simple, I can substitute z value here, so it is r raised to power n iota and theta plus 1. This is mode of r. So what is the mode of z? Mode of z is single r, so it is r raised to power n minus 1. Fine. So when it will, okay, you can scaling them, so what will happen? It is rn e raised to power iota n whole square plus 1 plus 2ab. Fine. This is r raised to power 2n plus 1 minus 2r raised to power n. So 1 will be cancelled out. What will happen? It is r raised to power 2n e raised to power 2n theta of this, minus 1 is a common, plus 2r of n e raised to power iota n plus 1 is here. Now you can think about that, which of the following, now r raised to power n is cancelled, so you can think about that. I can return this component as cos 2n theta plus iota 2n theta. Fine. This component I have written as cos plus iota sign. Look at the options. So firstly I need this, I need as a 0, so it means this component must be 0, this component must be 0, r is a non-zero, so this will be 0 when this number will be my 1, it will be 0, and this number will be my minus 1, so cos of n theta will be my minus 1. Fine. Once cos n theta will be minus 1, this number is a square, it's a plus 1, so this will be 0. Only the right answer is my C is the correct option. Okay, consider a function, holomorphic function, series is absolutely convergent. Remember, in the real analysis we already discussed any of the series f of nx converges uniformly what is that, Mn test will be applicable. Okay, so we have what is Mn test, or you can say it converges uniformly. Then what is the meaning of that? It is my nth derivative. So when any of these series will be convergent, you can think about uniformly convergent. So if I think about any of the series like of exponential nature, or you can see converges uniformly. If I say any of the GP series R if Fn, it is convergent when R is less than 1. So if I consider any of the function like of z by alpha is less than 1, say 3, fine, or simply take e raised to power z by 2. So what is the first derivative? 1 over 2 here. Second derivative 1 over 2 square e raised to power z by 2. And what is the nth derivative? E raised to power z by 2, 1 by 2 of n. Now clearly see that this is a uniform convergent. Why? It converges uniformly because this is a GP series, it is a less than 1 and it goes to the here. So it means this function will satisfy this property. Now look at, is it a constant? Is it a polynomial? Is it extended to the entire function? You can extend. This is a real, but this is a complex number. So the right answer is only C is the my correct option. Okay, this is a symmetric. So what is the meaning of the symmetric? Uy is equal to Vx. Fine. This is the case of the symmetricness. Then how you can solve this one? You can check about the option. So f is a polynomial. F is entire function, u and v are symmetric. Then here, okay, f is analytic. So ux is my vy, uy is my minus of vx. Fine. F is a polynomial, so you can think about any of the polynomial. If you want to discard the option, then you have to think about that. U of y is my vx, so both are same and it's a negative also. So what is the meaning of that? Uy will be 0, vx will be 0. Fine. So it means v is my constant or a function of the y, u is my constant or a function of the x. That is the only purpose of that. Now if I take v is a function of the y, so the derivative, and u is the function, that's true. Both may be the constant, both may be the 0, both are here. Now look at that. If I think about the first option, if I think about any of the function which is z, that is my polynomial, x plus iota y, this is my u, this is my v. If I think about here, what is the ux? 1, uy 0, vx 0, and you can see this is my symmetric. It satisfied this property and it's a polynomial. So the only condition is it should be the symmetric. Is it satisfied the entire function? You can see f of z is satisfied that. So the first option is the correct one. Polynomial of degree less than of 1. Less than of 1 is again here. So because less than 1 means it's a constant. So u and v are constant. So polynomial is also. It is necessary constant, cancel out because it may be a polynomial as well. Polynomial of degree 1, greater than 1. So if I consider this as a z square, so what is that? This is x square minus y square plus 2xy iota. You can see that is it symmetric? 2x minus 2y, but here it is 2y. Here you can see they are not symmetric. So it means this option is cancelled out. The right answers are A and B are the correct option. Okay, f is a non-constant entire function. Which of the following statement is my false? So how you discard the options? That's a very simple again. You can see this is my non-constant entire function. Fine, but which is about which of the following statement is a false? How you can say that? Okay, you can't say it's a discard them. Okay, we all know if f is my entire and bounded, what is the meaning of that? F is constant. Now they are opposite them. F is not constant. What is the opposite of them? F is not bounded. So that is a unbounded, but we need a false statement. So this is my true statement. F send open set to the open set, that's a correct statement by using the open mapping theorem. There exists an open set in the connected domain. F is never 0. F is never 0 on which then f of u attained at the sum point of the u. That's the wrong statement. Because what is the open mapping theorem? What is the maximum modulo principal set or the minimum modulo? If this is my minimum point or the maximum point and it belongs to the domain, then the function is my constant. But he said it's a non-constant function, so this is my false statement. Since only the one correct option is there, rest all options are correct, so this is the zero. Okay, which of the following statements are true? If an sequence AK is bounded, can you think about any of the bounded sequence? A constant sequence is bounded. Okay, so we can discard the options. Look at that. If is a bounded, so this is a bounded, that's a correct option. So this is my here, define the analytic function on this is. So what is that? This is the GP series of this. So what is that? This is the analytic whenever Z is less than 1. What is that? This is the open disk, that's the correct option. If this define an analytic function, so this is already defined the analytic function on here, then AK converges to the 0. Look at that. If I consider the same example, this satisfied property, he said AK will converges to the 0, but for this example you can see this is not goes to the 0, so this is cancelled out. If Fk and Gk are the two power series whose radius of convergence is 1, you can think any of the power series whose radius of convergence is 1. I can again think about here. This is my F, that is my AK is my 1, BK is my 1. So radius of convergence is 1. The product is also the power series, that's the correct. In the open disk, that's again here, because if you think about the product of them, it will be my here, and the product of them, if I consider CK all as my 1, this is again a open disk. If this has a radius of convergence 1, again I consider the same example by taking AK is 1, then F is continuous on the closed interval of this. That's a wrong, because look at this example. F is not exist at Z is 1, so it means F is not continuously at Z is equal to 1, so this option is cancelled. Okay, F is Z cube plus 1 sine of Z square. U and V, which of the following statements are true? Infinitely differentiable, continuous, bounded, and so on. This is my trigonometric function. Trigonometric function is differentiable infinitely time. This is the polynomial function. Every polynomial function is infinitely differentiable. It means function is my infinitely differentiable. Once the function is infinitely differentiable, the corresponding real component is my infinitely differentiable is the correct statement. U is continuous but not differentiable, that's the wrong option. F is my bounded, so U is my bounded. So what will happen? You can see F is my entire function, that is analytic function. If U is my bounded, what will happen? If U is bounded, F is entire, it means F is my constant. But you can see this is my non-constant function, it means this will not be true. F can be represented as a absolute convergence power series, that's true, because F is infinitely differentiable function, so you can apply the Taylor series, you can apply the Lorentz series, so it means it can apply in the terms of the power series is the correct answer. Okay, which of the Fn, that is my second derivative, plus F is my 0. Okay, can you think about, suppose the entire function F satisfied here. Can you think about that any of the function which satisfied this property? Look at the real numbers, y double dash plus y is equal to 0. So sine and cosine will satisfy me. So I can simply take sine of that. Fine. Then you have to check whether nth derivative is convergent or not. What is the first derivative at the point 0? First derivative will be my cos z. At the point 0 is 1. Second derivative at the point 0. Second derivative is my minus sine z, 0. What is the third derivative at the point 0? What is the third derivative is? So answer is minus 1. What is the fourth derivative at the point 0? Plus sine z, 0, and so on. So what is kind of the sequence you have? 1, 0, minus 1, 0, and so on. So clearly see that it has a 3 different points, 0, minus 1, 0. So not convergent. Fine. So it's a not convergent. Limit. What is the limit of this? If I call it this as an, what is the limit of the an? It depending upon that. If it is a even number, then 0. If it is a 3, it's a 1, it's a 1 or minus 1. It means limit is not unique. Once the limit is not unique, then it means there does not exist. So limit does not exist. They are not talking about the limit point. They are talking about the limits. And the only left is point here. You can see this is the absolute value. What is the absolute value of this is 0 or 1. It has a convergent subsequence. Okay. Look at that. Firstly, I will tell you the tip. Whenever the function is of this nature, g of z, then what is the answer of this is always in the form of g of number of the zeros. I call this as a ai, and multiplicity of the zeros minus g of the number of the poles multiplied by here. What is that? This is the multiplicity of the pole. This is the number of the pole. Ai is the number of the zeros, or ai is the 0, and this is the multiplicity of the zeros. Fine. Now look at the option. F is a holomorphic function. What is the meaning of that? F is my analytic. If f is analytic, it means f is my differentiable. Once f is differentiable, it means f has no pole. So once f has no pole, what is the multiplicity of the pole? That is my pi is my 0. Fine. So this component will be my 0. So now the rest option is number of the zeros. So look at this number of the zeros. F has only 0 at z0. So it means there is only one 0. What is the 0 is z0. If it has a multiple 0, then you can write as the summation part of this. So what is the multiplicity of the 0 is q. So it means this is my g of z0. Multiplicity of this 0 is my q. Now you can compare this function. What is the g? Is my z raised to power p. So the right answer of this integration is my z0 raised to power p into q. Z raised to power p q is the right answer of this problem. Okay, f is my entire function. F is my analytic function. F is a polynomial if. F is a polynomial if. Okay, is a power series, then an is 0. Okay, f is here, this and. Okay, you have your target is to prove is a polynomial. So if I consider this is my here, this is my power series where an is my nth derivative at the point center over n factorial. If he said an is my 0, so let an is 0, then target is to prove polynomial. If an is 0 for at least 1, so assume an is 0. What is the meaning of that? This is my 0 at the point of a. It means the nth derivative will be my 0. So if nth derivative will be my 0, so nth plus 1 derivative will be also be 0. It means up to the n minus 1 derivative, it has some finite terms. So what is the meaning of that? It has a polynomial. So it means the first option is the correct option. Look at the second option. If limit is there, what is the meaning of that? This is my, that is singularity is my pole. That is the meaning of this. That means z is my pole, and we already discussed the previous shortcut tricks. If this is the entire function plus singularity exists at the pole, then this implies this is my polynomial. So this option is also correct option. Look at the third option. What is given to you? What is that? F is bounded. F is bounded. F is entire. What is the meaning of that? It is my constant. f is constant, and constant is also be a polynomial, so this option is also correct one. Again you can see this is my bounded. Once f is bounded, it means f is a constant, it is a polynomial as well, so all are the correct options. Okay, look at that. My target is to find at the point 0. Firstly, check whether 0 satisfied is less than 1 plus 0. 0 is satisfied. It means I can think about this term less than of 1. I can think about any of the term which is less than of the 1. So say k is my constant. Any of it can be 0, it can be 0.1, it can be 0.3 and so on. Then our target is to find the f dash or f double dash. So can I find the value of the fz plus 1 minus of this into z? Fine. Now if I take the derivative, f dash plus f of z is equal to 0, 0 minus of e raised to power z. Then first derivative at the point 0. This value will be 0. This value will be f of 0 is my minus 1. Now we get f of 0 is my minus 1, but we need a f dash. Fine. So how you can find the f dash? So once we know f0, can we find the value of the f dash? I think yes, we can find that by using the previous formula. This value will be less than of f of z square 1 minus z square. So what is that? F dash of 0, 1 minus f0 is my minus 1 over 1 minus 0. So it is my 0. So f mod of them is less than 0, it's minus 1, but we need it exactly. Okay, we need an exact value. So how we can solve that? So I can skip this part. I can find the value of the fz from here, k plus 1 minus e raised to power z over z. So k plus 1, I can write e raised to power z as 1 minus z square by 2 factorial and so on divided by z. This cancel out. So k minus, I can divide it by z on both sides. So minus is common, 1 plus z over 2 factorial and so on. So what is that? F of z. So what is the f dash of z? So minus k over z square. Okay, it will be minus 1 over 2 factorial plus coefficient of the z. Now since it is an entire function, it has a finite value, so k must be the 0. Otherwise at infinity it will be the 0. So what is that? It is my coefficient f of 0 is my minus half. What is the f double dash? If you take the second derivative, it will be the z square by 3. If I take it must be the 0. So it is 0, it is my z square, it will be my 2 by 3z. So it is my, if I take the derivative, it will be my 0, it is my plus 1 by 2 factorial, it is my 2 over 3 factorial of z and so on. If you take the second derivative, it will be my 2 over 3 factorial is 1 by 3 is the right. Okay, D is the open disk, F is the power series, F is a constant. So F is my entire because it is given to you. Your target is to prove F is a constant. So again repeat, if I prove that F is bounded but it is nothing given to you. Now if F and F dash are my entire, what is the meaning of that? F is constant. So look at that. If I assume this is there, it means F is constant. That's the correct option. Look at that. That's the maximum or minimum modular principle. If I prove half belongs to the domain, it means u of half for all z will give you a maximum point. So by using the maximum modular principle, F is my constant. So what is the domain? Domain is the open disk. Center is 0 here. Okay, so half is lies between them, so it's a constant. Set n, an is 0 is infinite, then it is a constant. That's not true. That's a very simple example. An, power series, what is the an is? Nth derivative over n factorial at the point 0. At the point 0. If I take the first derivative, it is my cos z. Second derivative, sin z minus, third is minus cos z. Now you can see at the point 0, this value will be 0, fourth derivative will be 0, fifth derivative will be 0, and so on. It has infinitely many values of the 0, but this is my non-constant, so this option is cancelled. You can see about here, what is that? This is nothing but my f dash as per the definition of the derivative. So derivative will be 0, it means this is my constant, is the right answer. Okay, which of the following is a false? That's the image. When the image set will be my open. So by using the open mapping theorem, if you prove that this is the open, this is the closed, this is not the closed, this is the open, so A and D are my open by using the open mapping theorem. This is also the open mapping theorem. So if you prove that 0 belongs to this, which of the following set is open? This is the open set because it's the entire non-constant entire function. What is the result is? If you have the non-constant entire function, G is my open, then f of G is open. So your target is to prove this is a non-constant. E raised to power Z is a non-constant. This is also open, so it is my here. Similarly, sin Z is my open. Look at the modulus sin B. E raised to power Z. If I take x plus iota y, this is my e raised to power x only, which is a real. And clearly sees 0 does not belong to the e raised to power x. What is the meaning of that? This is my open, because you can find the neighborhood. So if this is open, this is the open subset here. Sin of z. You can see sin of z, you can write here, can 0 belongs to this? Yes, 0 belongs to this set A. 0 belongs to this set A. So once the 0 belongs to this, what is the, can you find, but because it's a modulus value, so this value A has always be greater than equal to 0. So it means this is my range of this. But if you take the open set of this, if you take this point, there is no open subset of this. So it is not an open set. So once it is not an open set, it will not be an open. Okay, look at the last question. Which of the following is my true for the positive definite? Okay, what is the negative definite? Simple tips for you. If I say this is my mapping from say x1, x2, x3, x4, it is said to be the non-negative definite or the positive semi-definite if x1 is my greater than 0 and the determinant of this x1, x4 minus x2, x3 will be my greater than 0. That's the meaning of the positive semi-definite. Look at the first option. 1 is greater than 0 satisfied. 1 minus c dash is my greater than 0. Is it true? We will see. C is my complex number, so I can take c as my z. Okay, so I can return this as of this. So 1 minus x square plus y square. So this, what is the set is? Complex number. It is given here. Now what is that? D bar is my collection of all those real numbers such that x square plus y square is less than 1, less than equal to 1. You can see 1 minus of this is always be greater than 0. So both the properties satisfied. So this belongs to the D bar. So first option is correct. This cancel, this cancel. Now look at this third and the look at the other options. Look at for the gamma 2. First 1 is greater than 0 satisfied. 1 minus c dash greater than 0, that's already satisfied. Now I can expand this option. So look at that. Find the determinant of this. 1 minus c bar minus of c bar minus 1, c bar minus c, sorry, this is minus c, this is c bar minus c of c bar plus of c, it is c bar of c minus of c bar. Fine. My target is to prove it is a greater than 0 or not. So if I open them, what is that? This is nothing but my 1 minus z square. Z into this is again z square. C, this is my z bar. Fine. So I can return this into z of z bar square. This is c bar of z bar minus z bar square. So what is that? This is 3 times here. I can take, this is nothing but my z bar. I can take z bar square as a common rest is z into z bar. So this is nothing but my 2 times of the x. So I can convert into a real numbers. So this is my common. What is that? It's a 3 minus 2x. Fine. So I can written this as x square plus y square 3 minus 2x. Now you can see mod of z is less than 1. 3 minus 2x, when it will be less than 1. So if it is a greater than 1, what is the meaning of that? It means minus x square plus y square 3 minus of, sorry, is a greater than 0. Fine, it will be greater than of minus 1, or you can see x square plus y square 3 minus 2x is less than 1. So when it will be happens? It will be happen only when this x will be my 1, or you can say, because this number is already less than 1, so this number will be less than of the 1, or you can say 3, this number is here, or you can see here. So what is the meaning of that? 3 minus of this, that is x is greater than equal to 1. But my set is given to you as x square plus y square is less than equal to 1. What is the meaning of that? That means x is my 1, y is equal to 0. So what is the meaning of that? D bar is my only set of 1 comma 0. So which that means this omega 2 is my here, which is not equal to D. So what is the meaning of that? This is not there. So the right answer is my C. First option is cancelled. C is my correct answer. So I hope you can simply learn the various tricks for the complete solution of this June 11 to 23. I hope you can like, share and comment this video to your friends. Best of luck, students. Thank you.